Hi everyone. Today we will see how to convert a decimal number into binary using sum of powers of 2 method. Okay, already we have seen one method called repeated division by 2 to convert a decimal number into binary, and this is the other method which can be used to convert a decimal number into binary. Okay, we will see how to convert this 98, okay, which is a decimal number, into binary using sum of powers of 2 method. Okay, the first step to be done is we need to write the powers of 2 starting from 2 power 0. Okay, start from 2 power 0. So 2 power 0, the value of 2 power 0 will be 1, and 2 power 1, it is 2, 2 power 2, it is 4, 2 power 4, 2 power 3, it is 8, 2 power 4, it is 16, 2 power 5, it is 32, 2 power 6, it is 64, 2 power 7 will be 128. So, we are starting from 2 power 0, but till what number we need to continue? Abdina, we need to continue till I get a number closely lesser than 98, closely lesser than the number which is to be converted. So, here till 64 only I am supposed to write. I need not write 2 power 7 because 2 power 7 will become 128. I need not go for 128 because the last value should be a lesser number than 98. So with this I will stop. I need not write this 2 power 7. And because I have stopped with this, okay, I need to put 1 under the 64. I need to put 1 under this 64. And because I have put 1 under the 64, the 98 is the actual number. With this 98, I need to subtract 64. Okay, so the answer will be 8 minus 4, it will be 4. 9 minus 6, it will be 3, 34. So now I should find a number which is lesser than 34. Okay, in this powers, I should find a number lesser than 34. And I have got 32. 32 is a number which is lesser than 34. And because 32 is lesser than 34, I need to put 1 under this 32. Okay, now because I have put 1 under 32, 34 is the difference I have got in the previous step. With this 34, I should subtract 32. With this 34, I should subtract 32. Now the answer will be 2. Okay, and I should check whether I am getting a number 2 or lesser than 2. In the previous case, I got 34, but actually 34 is not available. So that only I went with the number lesser than 34. But if you have a number 34 or 32 like that, or 16 or 8, if you get a difference as 16 or 8 or whatever it is, you can directly put 1 under that actual number. If we don't get the actual number only, we should look for the lesser number. And here the difference is 2. The difference is 2, and I am getting a number 2. Okay, I have got a number 2. So that put 1 under this 2. And because I have put 1 under 2, the previous difference is 2. So 2 minus 2, it will be 0. So till I get 0, I need to proceed this process. Okay, that's all. I need not proceed now. What should I do with the remaining things, remaining values? Abdina, wherever I have the blank spaces, I should fill that blank spaces with 0. So under the 16, I didn't put 1. Under 8 also, I didn't put 1, 4, and under 1. So wherever I have blank spaces, I should fill the blank spaces with 0. So that's all. The process is done. And what we have got is now the binary equivalent of this 98. So you can write 98 to the base 10 is equal to 11000010 to the base 2. Okay, the same value, the same answer you will get when you convert this 98 into binary using repeated division by 2 method. 98, that also we will check. When you divide, the quotient will be 49, remainder 0. Again, when you divide this by 2, 2, 4, remainder will be 1. 2, 1, 2 quotient, remainder will be 0. 2, 6 will be the quotient, remainder will be 0. 2, 3 will be the quotient, remainder will be 0. When you divide this 3 by 2, 1 will be the quotient and 1 will be the remainder. Now when I group the numbers from bottom to top, I am getting 1, 1, 1, 2, 3, 3 zeros, followed by 1 0 to the base 2. The same number I have got also using sum of powers of 2 method. So whenever you have a question like convert a decimal number into binary, if it is not mentioned in the question, you can also use the sum of powers of 2 method if you are familiar with. Or if this is easier, you can proceed with this method itself. But if the question is too specific, convert this 98 to the base 10 into binary using sum of powers of 2 method, then you should know how to convert using this method. Okay, we will see one more problem. Okay, now I have taken convert 65 to the base 10 into binary, and this is also using sum of 2 powers of 2 method I'm going to proceed with. Okay, so 65. I need to start with 2 power 0. 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 will be 64. When I go for next power, it will become 128. But I need to stop with the number which is lesser than 65. So with the 64, I'll stop and I'll put 1 under the 64. Because I'm stopping with this, the first digit should be 1. So that I have put 1 under this 64. Now the actual number is 65. 65 minus 64 is equal to 1. Find whether we have got 1. Yes, of course we have got 1. Put 1 under this one. And because I have put 1 under this one, this previous difference should be subtracted with this 1, and 1 minus 1 is 0. With this I should stop the process. Now what to do with this remaining spaces, Abdina? Just fill it with zeros. So this is the answer. You can even try this using repeated division by 2 method. The same value you will get. So here the answer will be 65 to the base 10 is equal to 1. 5 zeros followed by 1. This will be the answer. One more problem I'll do. Okay, now I am writing convert 128 to the base 10 into binary. So 128 is the decimal number. This number I'm going to convert into binary. So similar way, you should start writing from 2 power 0. It is 1. 2 power 1 will be 2. 2 power 2 will be 4. 2 power 3 will be 8. 2 power 4 it will be 16. 2 power 5 it will be 32. 2 power 6, 64, 2 power 7, it is 128. I have got an exact number which is equal to 128, so I should stop with this. So, you can understand, if we get an exact number equal to the question, I can stop with this. Otherwise, I should stop with a number which is lesser than the exact number, lesser than the question. So, here 128 is the question and I have 128 here in powers of 2. So, with this I should stop. Okay, I should not stop with the 64. Okay, always it should not be lesser. So, two things you should keep in mind. One is, if it is equal, okay, if the number we are getting is equal to the same question, with that we should stop. If we don't get the equal number, every time we won't get the same equal number. In that case, we should stop with the lesser number. Okay, so these 2 points you should understand. So here, because I have stopped with 128, I should put 1 under 128. So, because I have put 1 under 128, the question is 128 only. So, 128 minus 128, 0. With one step itself, the problem has got over. So, what to do with this remaining blank spaces? Fill it with zeros. That's all. That's all. This is the binary equivalent. So, 128 will have the binary equivalent as 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. 7 zeros. So 128 to the base 10 will be equal to 1 followed by 7 zeros to the base 2. The same way, same problem you can do with repeated division by 2 method. Check whether the answer is correct. Okay, hope you understood how this sum of powers of 2 method can be done to convert a decimal number into binary. Thank you.